Hey everybody, 4D Sparky here. I'm going to show you how to use a fault locator to locate a fault in an underground cable or electrical wire. And the way these work is there's a transmitter that you hook up to the wire and it sends a DC pulse through the line. And wherever the fault is, the electricity will spread out and it'll have a voltage gradient. The voltage will drop as it spreads out. And that's all these are, is basically a DC voltage generator and a DC meter. As the voltage drops as it gets away from the fault, there's a gradient where the voltage is higher at the fault than it is farther away. And this is a simple meter that will tell you the voltage difference. And simply using that voltage difference is to give you an idea of what direction the fault is. Now, one thing that I do as standard procedure is I locate the cable with a cable locator before I do the fault locate, so I know the path. I don't ever assume that it goes straight from point A to point B, because you never know how it was installed. They may have had to go around a trailer or a truck that was parked there, or maybe there's a big pile of dirt that they had to take another path around. So you want to know that location. It helps, certainly. You don't have to do this, but it helps, and to me it makes it go faster. So what I've done is, let's say we've got a cable under the ground here, and I'm going to pretend that this piece of number 12 that I've got laid out is that cable down underground, so you can get a better idea of how these things work. And I've taken a little bit of the insulation, I've stripped it back, and I'm going to take a screwdriver, and I'm just going to drive that into the ground. To simulate a fault. Now that's driven down into the ground. Now, since you are using a very high voltage DC pulse, this particular model, I don't remember if it's 1 kilovolt or 1.2 or 1.1, but still that's a lot of voltage, and you don't want to be sending that through the line when it's hooked up to a load. So what you want to do is locate both ends of the cable and disconnect them. The next thing you want to do is meg out the cable, because you may only have one out of a bundle or a cable assembly that's faulted to ground. So you need to figure out which one of those is actually faulted to ground, because if it's not faulted to ground, you're never going to locate the fault. It has to be faulted to ground. So with that done, I've got both ends disconnected. I'm going to hook up my locator, and I simply take one wire and connect it to my faulted cable, and the other I either use a ground stake or a screwdriver, and this is just a stake that came with my unit, and drive it away from the path. Now what this is going to do is it's going to send the voltage through the wire. The voltage is going to follow the path to the fault, and then it's going to try to return through this circuit here. So you have a circuit through the lead, through the wire, through the ground, up through this stake, and back to the unit. You're simply going to be setting up a DC circuit. This is going to pick up the voltage gradient as that power, that voltage, degrades over the distance from this fault. So by knowing the location of the wire, I can follow that location. And what I'm going to do is I'm going to turn the unit on, and it's going to beep here in a second. And all I have here in this is a little meter. And when I hear it beep, I know that it's sending out the pulse. And all I have to do is watch this meter, which direction it deflects. Does it deflect this way, or does it deflect this way? So, by knowing the path, I know roughly where to go. So when this deflects, when it beeps, it deflects this way, because right here is my fault. In fact, I'll make it easy and I'll put my utility knife there. Okay, it deflected that way. Now if I've got a long way to go, I can just keep following the path. Once I go past the fault, the meter will deflect the other direction. And it went that way. So that tells me that the fault is somewhere between here and here. As I get closer and start to straddle the fault, I will still get a voltage gradient. It deflected that way. Deflected that way a little bit. Move it a little. Now it's deflecting this way because this is closer and is picking up the gradient voltage across here. Now that basically tells me that I'm right over, doesn't necessarily tell me I'm right over the fault. I can simply take a line perpendicular to my A-frame and it could be anywhere along that fault. So what I do as standard procedure is I go around in a circle. It tells me it's that direction. It deflected that way. It deflected that way. That way. That way. I continue all the way around in a circle. That's my second test. My third test is where I think the fault is. I set the sensitivity down and look for a light. It kind of went that way. It went that way. It went that way. So then I start turning it right over the fault. Yeah, it kind of moved to the right. Now it should move to the left. Yep, move to the left. It kind of moved to the left. And this is how I actually pinpoint. Really went to that direction. Should go that way, it did. And I just keep going around in a half circle doing that. Now if you don't know where the cable is, it's simply a matter of triangulation. I can come along here and it goes that direction. It goes that direction. It moved a little bit to the left. Moved a little bit to the right. So somewhere along this line that's perpendicular to the A-frame is the fault. And you can see that right there. Now, since I don't know where the cable is, I'm going to repeat the process over here. Yeah, let's turn the sensitivity up a little. It moved that way. So I want to move my... Wait for another beep. It moved this way. So now it's perpendicular to this line, and you can see that it is. I'll come over here and do the same thing. It moved that way. Really moved that way. Oh, I should be this direction. Move that way. It moved that way. Move that way. I might be too close to this. Move this away. Now I'm getting a proper indication. I was just too close to that thing. Yep, and again, it's zeroing out. So somewhere along this line. So between that line, and this line, I should be able to triangulate roughly where it is. And then use the two other methods of this and going around like this to actually get this location down to the size of the palm of my hand. And it's never failed me using those three methods. So this is 480 Sparky. Go forth and locate.